Today we're going to be talking about adding and subtracting rational expressions, and essentially it's the same rules as adding and subtracting any other fractions. In that if, for example, you had something along the lines of 3/4 plus 2/4, when it has that like denominator, you would say, great, that's going to be add across the top 5/4. For a total of 5/4. So notably, you always make sure the denominator stays steady, and then you're going to add or subtract the numerator. Now, if instead you said 3/4 plus 1/2, what you first have to do is change this to the least common denominator, in this case 4, to make that become 3/4 plus 2/4 instead. Now a doable problem. And we're going to be doing the same thing, but involving rational expressions. So the same basic logic is going to work. We just want to be looking at whether or not they have a like denominator instead of just in terms of numbers if, let's say, it involved an x in there. In which case, great, you're going to be doing the same thing, but just tracing through those x's. So let's go ahead and take a look at an example of this. Before we look at the kind of written out, I want to kind of show you explicitly what's going on. Let's say we have x plus 3 over x minus 4 minus 6x minus 17 over x minus 4. In this case, we already have a like denominator. So in this case, we're not allowed to plug in x equals positive 4 because that would make our denominator turn to 0, but otherwise they have a like denominator. We're able to go ahead and just add or subtract according to what's the operation, just straight across the numerators. In this case, it's subtraction. So in particular, I would note subtracting in parentheses all of 16x minus 7 from x plus 3, and that would all be over the like denominator, x minus 4. In the same way that whenever we have 3/4 minus 2/4, that becomes 3 minus 2 all over 4. Same idea here. But since we have a parentheses for what's being subtracted, what we're going to do is we're going to go ahead and distribute that subtracting to both terms. So we're going to be subtracting 6x, and then minus a negative 17 becomes adding 17. Drop down everything else. And the only thing we still have to do is simplify the numerator entirely by combining like terms. So in this case, some like terms would include negative 6x and x would be one set of like terms. And then positive 3 and positive 17 would be another set of like terms, for a total of, let me not write with a highlighter here, let me write with a pen, negative 5x plus 20 over x minus 4. Now, once you get to this stage, it would be very tempting to call it done. However, if there is a greatest common factor still within that numerator or within that denominator, you want to factor that out. So in the numerator in particular, negative 5 is a greatest common factor. Negative 5x divided by negative 5 gets us positive x. Positive 20 divided by negative 5 gets us negative 4. And now we have a situation where this is x minus 4 divided by x minus 4, which is going to cancel to make 1, and our final answer would simply be negative 5. And that is written a little bit more explicitly in math type here. So let's go ahead and try these next two examples. So I'm actually going to encourage you to pause your video, try it yourself, and then compare with what we get. So both of these already have like denominators, so we're good to go. For the first one, you're just going to add across those numerators. Denominator stays the same, it's effectively your units, and then 22 plus 7 is going to get us 29 over 17x, and then that does not simplify any further. We're done. For the next one, there might be a little bit more going on, but they do have like denominators, so we're going to go ahead and just subtract right there across the numerator. Had there been more than one term attached with that 8y, I would have been sure to make sure to use parentheses there, but there's not, so I'm really just going to leave it as is, all over y minus 1. Then we want to go ahead and factor. So on the numerator here, 8y is the greatest common factor. 8y squared divided by 8y leaves us with y. Negative 8y divided by 8y leaves us with negative 1. And now, lo and behold, we're in a similar situation where y minus 1 divided by y minus 1 makes 1. And we're left with 8y as our final answer. Now let's discuss how to add and subtract rational expressions without like denominators. So if they do not have a like denominator, just like with regular rational numbers, you're going to have to create a like denominator. And a helpful way to organize your work is going to be to completely factorize each denominator and to vertically align whichever of those factors are going to match. So in the case of 12 and 18, they have both 2 and 3 in common whenever you prime factorize. Then you also want to drop down whatever's different. In this case, 2 and 3 are a little bit different. And then when you multiply them all together, 2 times 2 times 3 will give you that least common denominator of, in this case, 36. You can do the same thing with rational expressions. So what you're going to want to do is you're going to want to totally factorize both of those denominators. So if I factorize x squared minus x minus 6, that's going to factor into x minus 3, x plus 2, because negative 3 times positive 2 gives us negative 6, our last term, and negative 3 plus 2 gives us negative 1, our middle term. And x plus 2, well, that's already factorized, but I'm going to vertically align it underneath the other x plus 2. And then when I note their least common denominator, I'm going to write what they have in common just once, which is our x plus 2 here. And then I'm going to drop down what they don't have in common, in this case x minus 3, and that would be our least common denominator. So let's go ahead and practice how to then use that knowledge to actually approach either an addition or subtraction rational expressions problem. So we just acknowledged with this problem that the least common denominator would be x minus 3 times x plus 2. And then it might be helpful to specifically rewrite that first one with that factorized. So that first one is x plus 2, yes, times x minus 3. So we have x plus 2 times x minus 3 times x plus 2 minus 3 over x plus 2. Then we're going to have to convert these to have the same common denominator. Now, you might be kind of tempted to go ahead and cancel this out, so to speak. I would not do any of that until you've actually combined things, because that x plus 2 is going to have to stay a part of our least common denominator no matter what. So you're actually going to make yourself more work by pre-canceling that out, so don't do that. Instead, we want to go ahead and transform this second fraction to be in terms of our least common denominator by multiplying both the top and the bottom by x minus 3. Just like we would do in regular numbers, if I had 7 over 12 and I wanted to turn that to being over a least common denominator of 36, I would multiply both the top and the bottom by 3. In that case, the part of the least common denominator that fraction was initially missing in its denominator. Same deal here. This fraction is missing x minus 3, and if I multiply the denominator by x minus 3, I also have to multiply the numerator by x minus 3. Now this will simplify to x plus 2, and then over x minus 3 times x plus 2, minus, and then I'm going to go ahead and actually distribute that across its new denominator, 3x minus 9 over x plus 2 over x minus 3. And even though these denominators, one has x minus 3 times x plus 2 and the other one's x plus 2 times x minus 3, those are the same thing in the same way that 2 times 3 is the same thing as 3 times 2. What you're going to want to make sure you do, though, when you subtract is go ahead and put parentheses around that other numerator. And we're going to want to make sure to distribute that subtraction. Let me change colors here. Distribute that subtraction across those parentheses. So we're going to subtract 3x, then minus a negative becomes adding a positive, plus the 9. And we're going to drop down the x plus 2. And then that's all over x minus 3 over x plus 2. So once we have like denominators, we're just going to add or subtract across that numerator. Now I'm actually ready to combine our like terms. So x minus 3x will give us negative 2x. Positive 2 plus 9 is going to give us positive 11. All over x minus 3 times x plus 2 as our nice, beautiful final answer. Go ahead and pause your video and see if you can do this next one yourself. So for this next one, its least common denominator is just going to be x times x plus 1. You could sort of formally vertically align it, but there's not much to vertically align in this case because both of these are already completely factorized and they have no common factors with each other. So in particular, we're going to have to take 2 over x and multiply it by x plus 1 over x plus 1 because that's the missing part of its least common denominator. And 3 over x plus 1, we're going to have to multiply by x over x. Once we distribute that, we're going to distribute the 2 times the x and the 2 times the 1 to give us 2x plus 2 all over x times x plus 1 plus 3x all over x times x plus 1. And now we're ready to go ahead and add across the top. So that becomes 2x plus 2 plus 3x all over x times x plus 1. Combine like terms in the numerator. That's going to get you 5x plus 2 over x times x plus 1. And that numerator cannot be further factored, so that is simply our final answer. This next one looks like something I want to actually more formally find the least common denominator for. So I'm going to go ahead and find the factors of x squared plus 12x plus 32. So for that, I'm trying to multiply to 32 and add to 12. In particular, that should be 8 and 4, so that'll become x plus 8 times x plus 4. And x plus 8 is already totally factored into x plus 8. So its least common denominator is going to be they have x plus 8 in common, so I'm going to write that once. And then I'm going to drop down the x plus 4. So we're looking for a least common denominator of x plus 8 times x plus 4. Our first fraction is already over x plus 8 times x plus 4, but I might find it helpful to also factorize its numerator. So if I factorize the numerator, x squared plus 16x, that has a greatest common factor of x. X squared divided by x leaves us with x. 16x divided by x leaves us with plus 16, all over x plus 8 times x plus 4. And then minus, and then the second one we are going to have to also multiply by something in order to make it over that greatest common factor, in this case x plus 4. So we're going to wind up with, I'm going to distribute that 16 to both, 16x plus, and then 16 times 4 is going to get us 24, carry the 2, 4 times 1, 64, all over x plus 8 times x plus 4. And I'm already starting to notice that there maybe actually would have been some like terms going on, and that actually factoring that numerator didn't really do anything that would be helpful for me. So I'm actually going to unfactor that other numerator, even though he does factor that way. I'm going to keep him as x squared plus 16x. Now we're ready to actually distribute that subtraction to both terms because we're minusing that whole second term. So we're going to minus the first term minus the second, so we're going to have minus 16x minus 64. Drop down the x squared plus 16x, and that's all over x plus 8 times x plus 4. In particular, I'm going to notice that it looks like 16x minus 16x, that's going to combine to make 0. And what's left is x squared minus 64, and now that is looking factorable. So don't make the mistake I made earlier of factoring too early. If you do factor too early like I did, it's not the end of the world. You can always just undo what you did. It wasn't a false statement to write down its factored form, but had you had the x times x plus 16 minus 16x minus 64 written, you would have noticed that you would have had to sort of redistribute out and undo that factoring you just did anyway. So that's just a little aside there. Now that numerator, now we're at the point where we want to simplify this final answer. We've just got a single rational expression, so we do want to go ahead and factor what we can so that we can simplify the answer. And in particular, in x squared minus 64, that's the same thing as x squared minus 8 squared, so that's going to factor into x minus 8, x plus 8, because that is a difference of squares situation. All over x plus 8 times x plus 4, and whenever I have an x plus 8 divided by an x plus 8, that's going to cancel out to make 1, and my final answer will be x plus minus 8 over x plus 4. So for this problem in particular, we had to recognize that the least common denominator would be x plus 8 times x plus 4. That meant that we had to multiply the second term, both the numerator and denominator, by x plus 4 to give it that like denominator. Then we had to distribute that subtraction to both terms in the numerator of that second term. And then once we did that, we realized that it actually did simplify, and it did, after we simplified, factor, such that two of those factors were able to cancel for a nice, simple final expression. So I'm going to go ahead and pause and encourage you to try this next one yourself, and then we'll go over it together. So for this next one, again, we want to find the least common denominator first. So x squared minus 9 is going to factor into x minus 3, x plus 3, because that is a difference of squares situation. That's the same thing as x squared minus 3 squared. X plus 3 is already factored into just x plus 3. So the least common denominator is going to be x minus 3 times x plus 3. So that very first term of x plus 4 over x plus 3, what he is missing is the x minus 3. So I'm going to have to multiply both the numerator and denominator by x minus 3. For the second term, we notice that that already is over x minus 3 times x plus 3. So I'm actually going to leave that exactly as is. X minus 3, x plus 3. And I'll notice from my previous ones that it was actually helpful to unfactor any sort of numerator, so to completely distribute. So in this case, I'm going to distribute the x times x to give us x squared, x times 4 to get us plus 4x, negative 3 times x to give us negative 3x, and negative 3 times 4 to get us minus 12. All over x minus 3, x plus 3. And then we're going to make sure that we're subtracting the entirety of the second numerator. So minus 3x and minus 3 when I distribute that entirely. Now I want to combine like terms, and after I've combined like terms, I want to see if I can simplify this further by actually factoring. But first, let's combine like terms. And in particular, in terms of my x's, I've got a 4x minus 3x minus 3x. That will combine to make, negative 2x. So we'll have x squared minus 2x, and then negative 12 minus 3 will give us negative 15, all over x minus 3, x plus 3. This numerator now looks further factorable, because here I'm trying to multiply negative 15 and add to negative 2. That would be negative 5 and positive 3. All over that same x minus 3, x plus 3. And now we'll notice that x plus 3 divided by x plus 3 makes 1, and our final beautiful answer is x minus 5 over x minus 3. This next one is some addition, but we're going to be doing the same sort of thing. So here in particular, I'm going to want to find the factors of 2x squared plus x minus 3. This actually looks a little bit more worked factor because that leading coefficient a is not equal to 1. So in this case, I want to multiply to 2 times 3, so a times c, and add to b, which in this case is 1. So what's going to multiply negative 6 and add to 1? That would be positive 3x minus 2x, and then I'm going to drop down my other terms. Then I want to continue with my factoring by grouping. So in my first group, the greatest common factor is x. 2x squared divided by x is going to leave me with 2x. 3x divided by x is going to leave me with plus 3. Between negative 2x and negative 3, I want to pull out a negative 1 because there's a leading negative, and that will end up flipping the sign on both of those. So now they have in common 2x plus 3, and what is different is x minus 1. So in particular, I just noted that he's going to factor into 2x plus 3 times x minus 1, and 2x plus 3 is already just factoring into 2x plus 3. So the least common denominator is going to be 2x plus 3 times x minus 1. The second term is already in terms of that least common denominator. The first term will have to change into that least common denominator. So if I'm going to write this in particular, we've got 2x over 2x plus 3 right now. And in order to change that to the least common denominator, we'll have to multiply both the top and bottom by x minus 1. And then the second term we can actually leave as is, but I'll probably want to rewrite its denominator in terms of its factored form. Now we're going to go ahead and distribute. So 2x times x will give us 2x squared. 2x times negative 1 will give us minus 2. And then we're adding that to 9x plus 6. If you really want to think technically we're distributing the addition, you can. It's just that distributing, multiplying by a positive 1 doesn't do anything. And that's still over 2x plus 3 times x minus 1. Now we want to combine like terms. In particular, I noticed that negative 2 and 6 are going to combine to make 4. So we're going to have that equal to 2x squared plus 9x plus 4. So I'm rewriting it sort of in the standard order as well for a quadratic there. All over 2x plus 3 times x minus 1. Now I need to see if this is going to simplify. So in particular, I'm going to want to factor that numerator. So I'm going to rewrite that to the side to factor them. So for 2x squared plus 9x plus 4, this is again where that leading coefficient is not 1, so I'm going to have to do the formal factoring by grouping. In this case, to multiply to a times c is 8, b is 9. So I want to multiply to 8 and add to 9, which means I want to split that middle term into 8x plus x. Notice how I did not actually change the value of the problem. I am just setting him up for factoring by grouping. In my first group, their greatest common factor is 2x. 2x squared divided by 2x leaves us with x. 8x divided by 2x leaves us with 4. In the second group, x plus 4, its greatest common factor is 1. And dividing both of those by 1 leaves you with itself. Now what they have in common is x plus 4, and after dividing both of those terms by x plus 4, I'll be left with 2x plus 1. So that means that what I just found will simplify to 2x plus 1 times x plus 4 all over 2x plus 3 times x minus 1. And that is actually as simplified as we're going to get. There are no other common factors to cancel out there or anything, so that just is a final form. Notice how I can't cancel out those two x's because they're adding two different terms, and that's considered one term there in a parenthesis. So unless that full parentheses matches, you can't cancel anything out. So just to recap with all of these, if they already have a least common denominator, then you can go ahead and just add across the top, subtract across the top. So 22 over 17x plus 7 over 17x, 29 over 17x, call it a day. Both over y minus 1, great, you're going to go ahead and subtract those guys. Go ahead and factor. And then if something is divided by itself, that will cancel to just be left with your final answer. If they're not already set up that way, you're going to have to make it set up that way. And how do you do that? By finding the least common denominator. And once you've found that least common denominator, the vertical alignment can be a good strategy for that, but however you find that least common denominator, you're going to want to make sure both terms look like they're over that least common denominator by multiplying both the numerator and denominator by whichever part of that least common denominator you're missing. And then you're going to want to make sure that if you're subtracting, that you distribute that subtraction to all the terms in the second term's numerator. And then you're going to want to combine all like terms, and then if it's the case that after you combine all like terms, what's left is factorable, you'll want to go ahead and factor that just in case something remaining actually cancels out. Although a lot of times it won't actually cancel out, it'll be more like this last problem where it just stays how it is.